Hello everybody, this is the video clip for section 4.5, which is about the chain rule. Okay, so here we still in chapter 4, a function of several variables. In calculus 1 we have learned the chain rule. For example, if your function y is a function f of u and your u is a function of x, like this, then what you can find is a derivative of y with respect to x. Okay, and you first find a derivative of function f with respect to a variable u, and then followed by a u with respect to a variable x. Okay, and if you write this way, it seems that okay, that it looks like a fraction, and then the top and the bottom cancel, and then what you end up with is the one that you would like to find. Okay, or I mean, you can use this kind of notation as well. Okay, so that it will just look exactly like what you really need on the left hand side. Okay, so the first one about the chain rule for several variable function is that if your set is a function of x and y, okay, and this function is called the f, this one is differentiable, so it means that you can find f sub x and f sub y, but then your x is a function of t. Okay, this x is a t of t, and your y is a h of t. Okay, so your x and your y is a function of one variable. So if you want to draw a diagram, you may saying that your z, okay, or your f is a function of x and y, and your x is a function of t, your y is a function of t. Okay, so if you want to find a derivative of z with respect to t, there are two possibilities. The first possibility is go through this red path, which is through the x, and the second possibility is go to the green path, which is through the y. So by this possibility or this contribution, you are going to add them together, or let us use the word combine. Okay, you will combine both possibility together. Okay, so this one, what you are going to do is that you first finding a derivative with respect to x for the z. However, because your z is a function of two variable, so you are going to use the curve, okay, instead of straight d. So you have a curve f by curve x, or df by dx, but then you follow by a derivative of x with respect to t. So you just because it is a single variable, you can just use a straight d. So it is a dx by dt. And again, if you look at it this way, that hey, is look like a fraction, then these two cancelled. So for the first contribution, you got what you really need on the left hand side. Okay, but don't forget that you need to combine or possibility. So this addition, just you should look at it as a combination. Okay, not really add them up. Okay, so for the second path, if you go through the y, then you find a dz by dy, followed by the same thing, dy by dt. So as you look at it as a fractions, then these cancelled, and here for the second term you also got what is it that you need on the left hand side as well. So this one is a two contribution that you are going to get from this kind of derivative, okay, using the chain rule. So for example, if your z is 2x squared y plus y squared, and your x is a sine t, your y is a cosine of 5t, you want to find dz by dt. And just notice that if you want to find dz by dt, because right now your t is a final variable, which is only one variable, so we use a straight d instead of a curve. Okay, so this one is the dz by dx. Okay, just using this diagram, and then multiply by dx by dt, and combine with dz by dy multiply with dy by dt. Okay, so the first one, a derivative with respect to x, so your y now is a constant, so the 2 and the y are constant. A derivative go directly to x squared, so you have 2x, and then because your y is a constant in this context, so you got a 0 as a derivative with respect to x. And then here your x depends on sine t, so a derivative become a cosine t. Okay, next, if you want to find a derivative of your z with respect to y, now your 2x is a constant, so you got your 2x squared, sorry, we got square as well, and a derivative go directly to y, so a derivative with respect to y is 1. Okay, and the second term you got a 2y, and here to find dy by dt, because it is a cosine, so you have negative sine 3t, and then a derivative of the inside, which is 3 right there. Okay, so this one is your dz by dt, and you don't really need to go any further. Okay, this will be a good enough to be your answer. You don't really need to plug in each x and y into a t variable. Okay, so for example, this one you will finish it with 4xy cosine t, and then this one can be 2x squared plus 2y, and then negative 3 sine 3t. That will be good enough for your answer. Okay, don't need to plug in your x to be sine t, your y to be cosine 3t. Okay, because actually this is the advantage of using the chain rule. Okay, so let's look at the second problem. The second problem is saying that your z is a function f which is depends on x and y, and your x also depends on s and t, your y depends on s and t. Okay, so it means that if you need to draw a diagram, you got your z here, your z are x and y depends on, and then your x depend on s and t, your y also depends on s and t. So this means that if you want to find a derivative of z, first thing you can find a derivative with respect to s, and to go through to reach the s right there, you can go through the path, okay, passing the x, or you can go through the path passing the y, just like that. So again, you got two contribution, okay, to reach the s. So you are going to combine these two contribution together, and because at the end your z is a function of both s and t, so to find a derivative of z with respect to s, we are going to use a curve. Okay, so to find this one, you are going to passing through the x first, so you find dz by dx, and then your x will go through s, so you have dx by ds, and again, as you take a look as a fraction, these can cancel, and then the leftover is the one that you need on your left hand side. Okay, and for the second contribution, you go through the y first, so you got dz by dy, and then your y go through s, so you have a dy by ds follow, and then again, as you do cancellation, I mean pretend to do cancellation, you got dz by ds, which is the leftover that you need on your left hand side. Again, this addition, don't look at it as the addition, is a combination between these two contributions. Okay, so if you want to reach the t, okay, that will be the same thing. You can go through x, or you can go through y. Okay, so if you go through x, you are going to have dz by dx and dx by dt. You go through y, you got dz by dy, and then dy by dt, just like that. Okay, and so for example, let's look at this problem. you got log of xy plus x squared, and then your x depends on s and t like that, your y depends on s and t just like that. So if you need to find dz by ds, let us write down a formula first. So dz by dx, dx by ds, and dz by dy, dy by ds. Okay, so the z by ds, it is a logarithm. So you got 1 over xy plus x squared, and then a derivative of the inside with respect to x, right? Just like that. And then you need to find a derivative of x with respect to s. So here's the one with respect to s. So your t is a constant, and then a derivative of s with respect to s, you just have 1. So the second term, you need to find a dz by dy. So you have the same thing because you got a logarithm, and then a derivative of the inside with respect to y. Okay, after that you go ahead and find a derivative of y with respect to s. So this one survives, this one goes to 0, so you have 1 plus 0. And then you continue further to find a derivative with respect to x. Okay, so here the first term, you have y and 1 and 2x, right, for the second term with respect to x, and this is the one at the bottom, and then you multiply with t, and this one the derivative with respect to y, so that is x, right, and then this one will goes to 0 because right now your y is a variable, and then a 1. Okay, and again, you don't need to plug in x and y in terms of s and t. This will be good enough to be your final answer. And again, that's the meaning of using the chain rule. Okay, so if you just plug in everything to be s and t, then we don't really need the chain rule. So let us look at the second one, the dz by dt. So again, it is a dz by dx first, because to go to the t, you need to go through x first, and then dx by dt, dz by dy, dy by dt. Okay, you got two contribution. So the first one, again, you have a logarithm, so you have 1 over xy plus x squared, and then a derivative of the inside with respect to x, so you got y and 2x, and then dx by dt right now. So here is your constant, your t is a variable, so you got a 1, and then dz by dy, so you have 1 over xy plus x squared, and a derivative of the inside, which is y and 0, and then now dy by dt, so you have a 0 plus 1. So please also notice that, and this one, maybe look at this one better. This one and this one, they are the same. This one and this one, they'll be the same. Let me just change it into the same color. You see, because here the first term always dz by dx, you see, and then the second term always start from dz by dy. Okay, so if you do it right at once, then to find the other partial derivative using the chain rule, you can just copy it down. Okay, the one that will change will be the one behind here. Okay, that will not the same. All right, now we can elevate ourselves a bit, okay, by using like several more variable. For example, if you, okay, it's a function of n variables, okay, not only 2 or 3 but n variables, and each of the xi, okay, of u, so it means that your u maybe depends on x1, x2, x3, up etc. up to xn. Okay, and then each of the xi of u is a function of another m variables. Okay, Then the derivative, okay, so it means that your x, for example, your x2 is a function of t1, t2, etc. to tm. So it means that you are now, if you want to draw a diagram, then your u depends on x1, x2, etc. to xn, and your x1 depends on t1, t2, etc. to tm. So if you want to find a derivative with respect to of u with respect to some of the final variable, for example t2, then you need to go through your x1 as well as your x2 as well as your x3 and then up to xn. Okay, so it means that if you want to find this one, a derivative of u with respect to ti, then you start go through the x1 and then find the derivative with respect of x1 with respect to ti, and you go through x2 and then derivative of x2 with respect to ti, etc. to derivative of u with respect to xn, followed by a derivative of xn with respect to ti. So each term, okay, if you pretend to do a cancellation, the one that's left over is the term on your left hand side, you see each one of them, and then the plus sign here is a combination of each of the contribution. Okay, it's not really the addition. All right, so let's look at this example, and it will be better if you really draw a diagram. So your u, it is the function of x, y, z, you see x, y, z, and then your x is a function of two variable r and s, three variable t. Your y is also r, s, t. Your z is also r, s, no r. Okay, it's okay. So your z is only the s and the t. Very good. And you need to find a derivative with respect to s. So you try to find where is the s. So you see you got three contribution, three possibility that you can reach that s. The first possibility is through the x, the next one is through the y, and the third one is through the z. So it means that in order to find this derivative, you need to have three contribution. So the first one through the x, and then dx by ds. The second one through the y, and then dy by ds. And the last one through the z, and then dz by ds. Okay, so your du, so here is the u, du by dx will be just y, and then 2xz. Okay, so I'll do it faster than what we have done. All right, because you guys should be pretty familiar with. Okay, and then a derivative with respect to s of the x, so you have r e to the t, because that one becomes 1. And then a derivative of u with respect to y, the only term survive is the first term, the second term goes to 0. And then your y with respect to s again, so you have only r squared t. And the last one, derivative of u with respect to z, the first term has no z, it will be go away, and then the second term, the x squared survive. And dz by ds, so here's the s, so the derivative become 1, and then you got a cosine t. Okay, and you just leave it like that. That can be your final answer. Okay, and then we'll need you to do a DIY on the du by dt or du by dr. Okay, for du by dt, you need to see that, hey, you got three contribution again. However, for du by dr, it will remain only two contributions. Okay, so make sure that you can do these two problems. Now let's look at the next problem. It's a bit complicated. Okay, So this one, instead of finding the first derivative, but you are going to find the second derivative of your set with respect to s and t. Okay, but as we told you before, that if you write down this way, then it means that you do the one with respect to t first, followed by the s. So let us draw a diagram first, that your z depends on x and y, and your x depends on s and t, your y also depends on s and t. So to find a derivative with respect to t, you are going to go through two contributions, okay, either through the x or through the y. So let's look at this one first, dz by dt. So it will be dz by dx and then dx by dt, and the other contribution dz by dy and dy by dt. Okay, to find the second derivative further with respect to s, so it is a d by ds of dz by dt. Okay, so you already have this one, right, the dz by dt. So you just plug it in. So what you are going to have is d by ds of dz by dx and dx by dt, and d by ds dz by dy dy by dt. Okay, so you just separate the addition, okay, with a derivative like that. However, I mean, because your z is a function of x and y, and then your x is also a function of s and t, so this dz by dx is also a function of s and t hidden. And of course your x is already a function of x and t, so this one also has s and t hidden. So if you need to find a derivative with respect to s further of this two of this product, you really need a product rule. So it is the first and then derivative of the second plus the second derivative of the first. Okay, so this one is from your first term here. Okay, and then for your second term you have same thing, because here is a function of x and y, but your x and y depends on s and t, and this one your y depend on s and t at the beginning. So here you got s and t hidden, and you need to find a derivative with respect to s. So you need to use a product rule. The first derivative of the second plus the second derivative of the first. Okay, so here is your second term contribution. All right, so let's look at it carefully. Your s and your t, okay, your s and your t is the same level of a variable. You see here your z is up there, and your x and your y is right here, is a second level, and your s and your t is right there as a third level. So this means that if you want to find a derivative with respect to s of this function, it is just combined to be dz by dx and then d2x by ds dt. Okay, because your s and t are the same level of variable. Okay, then for the term follow, you got dx by dt, and this one, you see here is dz by dx, so you need to look at this one as up here. Okay, so your z or dz by dx will depends on the two things x and y, but then your x and y depends on another two things, s and t. So this means that for this one you need to use the chain rule. Okay, you need to use the chain rule, just like you need to go to reach the s, okay, by using two contribution through x and y. So this one you are going to distribute into two combinations, right? The first one, it is your d by dx, because you are going to go through the x first of this function. Instead of z, you are now working with a function dz by dx, but then dx by ds. Okay, look at this one more time. If you just cancel this two, okay, if you just cancel these two, what is it that you end up with? You have d by ds of dz by dx. You see, so this is the first contribution through the x, but then you need the second contribution through the y as well, and dy by ds. Okay, so this means that if you cancel this, your dy, you got this one left, which is the one that you need as well. Okay, so each of the contribution go to this same thing. All right, so it is the same as you did with your chain rule here for the first derivative, but right now instead of working with z, you're working with dz by dx. Okay, so this is only that red term highlighted here. Now let's continue further for the following. This one again, your s and your t, they are the same level of variable, so you can just go ahead and combine d2y ds dt. But if you look at the last one again, this one is a function of x and y and a derivative with respect to s, so you are going to use the chain rule, okay, just like that. So let me just highlight it with a green. So the green one will be here, d by dx, okay, a contribution through the x first, and then a function. Right now instead of z alone, you got dz by dy, and then dx by ds. You see, if these two cancelled, this is the leftover, and it is the same as what you need. And then d by dy, okay, contributions through the y of the function, and then dy by ds. Okay, look at it again. These two cancel. Your leftover is this green highlighted. Okay, and then you can simplify it a bit. This one is dz by dx, okay, d2x by ds dt. Okay, you cannot do anything further. This is look at this one first. Here is actually d2z by dx square. Okay, and then this one you can just distribute into each of them. So you got dx dt, dx ds, and then here this one is a d2z by dy dx, and this one can distribute into there, so you got dx dt, dy ds. Okay, and then with this red term, this was already done, so you got nothing but copy it down. For the blue term, this one is a d2z by dx dy, and here you can distribute inside, so you have dy by dt, dx by ds, and then this one is just simply d2z and then dy square, and you distribute this one inside, so to have dy by dt and dy by ds. So here, I mean, what you end up with, okay, here it is your d2z by ds dt. Okay, so it distribute into 1 2 3 4 5 6 terms. Okay, into 6 terms. Are we all right? Okay, so this one is d2z by ds dt. Of course, I mean, if you want, then you can do it by yourself to go ahead and find d2x by ds square, or d2, I'm sorry, not d2x, d2z by ds square, or d2z by dt square. What will happen? Okay, which one will be simplified, or which one can be combined? You really need to try it by yourself. All right, now let's look at this one instead. We have your z equals to f of x minus y. So actually this one can be written as z equals to f of t, and then t equals to x minus y. So your z depends on t and your t depends on x and y. So if you need to find dz by dx, it is go through the t and then to the x. So instead of writing it this way, because your z is a single variable, we are going to use a what? A straight d. Okay, so it is a z by dt, and then dt by dx. We use a curve because here your t contain 2 variables, so you have nothing to do with the z because we don't know what it is. But your x with respect to your t with respect to x, you got 1 minus 0. Okay, how about dz by dy? It is again dz by dt first, okay, through the t, and then go ahead to find a derivative of t with respect to y. This one got nothing but dz by dt, but here 0 minus 1. Okay, so if you add them up, of course we have a positive dz by dt and a negative dz by dt. So as you add them up, you got 0. Okay, so let us stop this video clip at this point. Okay, we still have one more concept in this section, but we'll continue with the part 2. We'll see you then. Bye bye.